Okay, welcome to our lesson on dividing polynomials. So last lesson we had a look at an introduction to polynomials, what they are, and some really simple things we can do with them. So we had a look at adding, subtracting, and multiplying, and we spoke about the idea of dividing them, but we didn't quite get to that last lesson, so that's what we're going to do today. We're going to have a look at dividing polynomials. One other thing to note from last lesson is the idea of equating coefficients. So that's what we did just here. And this technique is going to come up pretty heavily throughout today's lesson. It's what we're going to do in order to divide our polynomials. Okay, so there are a few techniques you can use to divide polynomials. The first one is long division. We're not going to formally teach you long division in this course. It's not entirely relevant to the syllabus, and the course is quite tightly packed, so we're not going to do that. There will be some resources if you would like to go and learn it yourself, though. The technique that we're going to use is equating coefficients, and like I said, we started learning this in our last lesson. So some important points before we get started. When we divide a polynomial p of x by another polynomial, d of x, so the divisor, that's why we're giving it the letter d, we obtain the answer that we get is another two polynomials, so the quotient and a remainder. And you've heard that idea of remainder before, just thinking about back to when you divide simple numbers, you have a remainder sometimes. So sometimes in maths, when something sounds a little bit complex, we think about a really simple example or use some really simple numbers in order to make sense of that, and then we put it back into our complex language. So that's what we're going to do here. So let's take this notion, but use a really simple example. So think about 31 divided by 3. So 31 divided by 3 is going to be 10, but you'll have 1 left over, so that's your remainder. 31 divided by 3 is equal to 10 remainder 1. So using the terminology that we learned over to the left, we divide a polynomial by a divisor, so d of x. So this would be our polynomial p of x. And we're dividing by the divisor, d of x. The things we obtain, the answer is the quotient and a remainder. So this would be our quotient, and this would be our remainder. And at the moment, they're all polynomials. A remainder can just be a number, or it could be 0. Okay, so we know 31 divided by 3 is equal to 10 remainder 1, and they're all the little technical symbols we can use for those parts of the equation. Think about that in another way. We could also think of that as, well, 31 is equal to 3 times by 10 plus 1. So 3 times by 10 would get you to 30, and then you would have to add another 1 on, to add the remainder on, to get back up to 31. So we could go and label all of those things again. So they're the same as what they are up here, they're just written in a different way. So the 31 was our original polynomial, p of x. Our 3, we set up here, was our divisor, so that's my d of x. My 10 was my quotient, my q of x. And my 1, as we set up here, was my remainder. So we can rewrite a division scenario like this, with our polynomial at the front and the other stuff all to one side. So p of x is equal to d of x multiplied by q of x plus a remainder, r of x. So what we're going to do now is use that, we call that an identity. So we'll write it neatly, you guys can copy it down, and we're going to use that identity to divide other polynomials. So at this point, I would pause the video and copy down p of x is equal to d of x multiplied by q of x plus r of x. So polynomial, divisor, quotient, and remainder. One thing to note with this identity, a remainder, r of x, could be equal to 0. You might not actually have a remainder. Or r of x will have a degree less than what the divisor is. So if you're dividing by a linear, your remainder is going to be a constant. Another thing to note is if r of x is equal to 0, So if this up here was equal to 0, you would only have this. You would have p of x is equal to my divisor multiplied by my quotient. Or in other words, my original polynomial, if I divide by my divisor, I would just be left with my quotient with no remainders left over. What does this tell you about d of x? What does that tell you about our divisor? Well, let's have a think about it. If I don't have a remainder, I have p of x is equal to d of x times q of x. All I've done is break down my original polynomial into two things that are multiplied by each other. Think back to year 9 when you learnt factorizing. Isn't that what factorizing is? Isn't that breaking down our one polynomial into two things multiplied together? So all we've done is break down our polynomial into two factors. So if our remainder is equal to 0, that tells you, well, d of x, my divisor, must be a factor. It must be a factor of my original polynomial. So that's something to keep in the back of your mind as we go through this dividing process, because that'll come up again. And it's kind of cool. It makes sense. Okay, let's have a look at actually using this technique of equating coefficients in order to divide polynomials. Best way to do this, easiest way to do this, is just to jump in and have a go. We learnt the technique of equating coefficients yesterday. This example is taken straight from the textbook. So we want to divide 3x cubed by 2x squared minus x minus 2 by 2x plus 1. And I could write that like this. Oh. But we also know when we're dividing a polynomial by a divisor, another polynomial, we have this identity we can use. We know that p of x is equal to d of x times q of x plus r of x. So that's what I'm going to write. I'm going to rewrite that identity that we worked out for ourselves. Now I'm going to go and substitute my actual polynomials that I know into that and work out the bits that I don't know. So I know that my original polynomial p of x is 3x cubed plus 2x squared minus x minus 2. And I know that because the question gave it to me. Is equal to, I know my divisor as well. I'm dividing by 2x plus 1. So my d of x is going to be 2x plus 1. That has to be multiplied by another polynomial. We don't know that other polynomial, so I'm just going to leave that one as q of x, my quotient. And then I also have possibly this remainder on the end. So we're kind of at a point now where we haven't been given any other information, so we need to start thinking logically about this. Okay, my original polynomial has a degree of 3. It's a cubic. I'm dividing by something that's linear. This has a power of 1. So my highest power over here is 1, and my highest power over here is a 3. These two things, these left-hand side and the right-hand side, have to be equal to each other because there's an equal sign in there. So in order to get my right-hand side equal to a cubic, I'm going to have to multiply a linear by something. Thinking back to index laws, when I multiply two things together, the powers add. So I would multiply, my quotient must be a quadratic. It must have a power of 2. In order to get a cubic, I need to multiply a quadratic and a linear together. So I know my quotient has to be a quadratic. It has to have a power of 2. So I can do something with that. I can say, okay, well, I haven't done anything to, let's stick with one color. That stays like that. This one is a quadratic. I'm just going to write the general form of a quadratic. ax squared plus bx plus c. And I still have this remainder. Now my remainder has to be a degree lower than my divisor. This one's a linear, so it's going to have to be a constant. And my left-hand side hasn't changed. So I've got 3x cubed plus 2x squared minus x minus 2. Okay, now we're at the point where this line of working looks exactly the same as what we did in our last lesson. We can now use equating coefficients to solve for what these letters are and therefore work out what our answer to our division is. Okay, In order to do that, I'm going to need to expand these brackets out though. So I'm going to use the distributive law. So everything in one set of brackets has to be multiplied by everything in the other set of brackets. So my 2x has to be multiplied by everything in the other set of brackets. And my plus 1, has to be multiplied by everything in this set of brackets as well. And I still have this little remainder tagged onto the end. So expanding those things out, I've got 2ax cubed. I've got 2bx squared. And I've got 2cx plus ax squared plus bx plus c. And I still have this plus r. This looked pretty messy, so let's go and simplify that one. I'm going to collect my like terms, and I'm going to kind of factorize them at the same time. This is the only one with, with a power of 3. So that just stays like that. Let's go and collect all of the ones that have a power of 2. Probably should use a different color. Nope, that's okay. So I'm going to factorize at the same time. It's going to bring my x squared out. I've got 2b plus a. Collecting all my linear terms, 2cx and bx. I'm just going to factor out that x, 2c plus b. You don't have to do that all in one step. You can break it down into 2. And then my linear terms, I've just got my c and my r left over. That looks a little bit neater than before. In fact, it looks neat enough now that we can go and actually equate those coefficients. So over here we've got 3x cubed, 2x squared minus x minus 2. So everything, all the coefficients of x cubed on this side should be exactly the same as the coefficients of x cubed on this side in order for these two things to be equal, which is what our equation is telling us. They are equal. So 3 has to be equal to 2a in order for this equation to be true. So I can go and work that out. Therefore, a is going to equal to 3 over 2, nice and simple. Looking at my power of 2, so my quadratic terms, my coefficient is a 2 over here, and I've got 2b plus a as the coefficient of x squared over here. So in order for these two things to be equal, my 2 has to equal 2b plus a. Good thing is I know my a value, 2b plus 3 over 2. So let's minus the 3 over 2. So I'm left with a half is equal to 2b. Therefore, b is equal to a quarter. So that's just some simple algebra there. Let's go and equate our linear terms, our linear coefficients. Over here, my coefficient of x is a -1. And over here, the coefficient of x is 2c plus b. So -1 has to be equal to 2c plus b. I know my b value. I can go and write that in. Plus a quarter. So I'm going to have to minus off a quarter over here. So I'll be left with -5 quarters is equal to 2c, which means my c value, if I divide that by 2, is going to be equal to -5 over 8. I've got my a value, I've got my b value, I've got my c value. The last thing to work out is the constant terms. So my constants over here are -2. So -2 has to be equal to the constants over here, c plus r. I know my c value, -2 is equal to -5 over 8 was my c value, plus r. I want r by itself, so I'm going to add 5 on 8 to the other side. -2 is the same as -16 on 8. Just to make that really clear how we're going to solve that one. If I add 5 on 8, I'll be left with -11 on 8. is equal to r. I've done the hard bit now. All I'm going to do is go and put these a, b, c, and r values back into the equation that I wrote up above. So the equation I wrote up above was this one here. So I'm going to go and put everything back into there. 3x cubed plus 2x squared minus x minus 2 is equal to 2x plus 1 multiplied by my quotient, which I now know, so my ax squared plus bx plus c. I know my a, b, and c values now. 3 on 2 x squared plus 1 over 4 x minus 5 over 8 because my c is a negative. And then I have the last thing was a remainder. And I worked out that my remainder was negative 11 on 8. So I can say, using that identity that we worked out for ourselves at the start of the lesson, my original polynomial can be written as my divisor. So if this was p of x, this was d of x, this was my quotient, and this is my remainder. So thinking back to how we then translate that back, so scrolling right back up to the start of the lesson. Where are we? My polynomial, my original polynomial, divided by my divisor, is equal to my quotient, remainder, whatever the remainder is. So let's go and say that. Therefore, to answer this question, 3x cubed plus 2x squared minus x minus 2 is equal to, divided by 2x plus 1 is equal to my quotient, so 3x squared cubed, plus 2x squared minus x minus 2 divided by, my divisor was 2x plus 1, is equal to a quotient remainder negative 11 on 8. So that's the technique we use to divide polynomials. Like I said, you can divide polynomials using long division as well. That's just another version of the solution. It's the same thing. That's just me checking my answer. You can use long division. It'll give you the exact same answer. I personally like equating coefficients. It makes a little bit more sense. You can logic it out if you kind of forget the process. You think back to those simple examples. But that's how we equate coefficients. Your textbook exercise is exercise 8B. I will put up on the OneNote the exact questions that you have to do. It won't be all of 8B. I'll let you guys know. Have fun.